Hey there, my name is Oliver Jen. I'm a chemistry tutor and a professional mentor for Go Bud Go. I love teaching chemistry. I've been teaching chemistry on the side for the past, I want to say about 6 years or so. I've helped about probably more than 100 students in high school and college chemistry succeed and do well in their classes. So with the recent events, with the events of the past year, I've been forced to go online, and teaching online has never been better, honestly. So let me show you exactly how I go through a lesson. Alright, so today I want to take you through a lesson for thermodynamics. For thermodynamics, this is the situation where you have the Gibbs free energy is equal to the enthalpy of the reaction minus the temperature times the entropy. Now each of these variables is really important. Delta G dictates the spontaneity. Delta H is essentially the heat. Delta S is essentially the randomness or the chaos of the system. Alright, so the Gibbs free energy here, what this is defined as the measure of the spontaneity for a given process. If delta G is less than 0, this defines a spontaneous reaction. You can think of this as something like blinking or sleeping. You don't really need much energy to do this just happens. However, if your delta G is greater than 0, this means that the reaction is not spontaneous and will actually require energy to occur. This is like exercising, this is like turning on Zoom to go to school. This takes work to do, essentially. Alright, so now we move on to delta H. Delta H is called the enthalpy. Now, enthalpy is, you can consider it as the heat given off from a chemical reaction. This is defined as the heat that is either absorbed or released during a reaction. And if delta H is greater than 0, this means that we have an endothermic reaction. Whereas if delta H is less than 0, we have an exothermic reaction now. And there are many ways to calculate delta H, the easiest of which is to use the enthalpy of formations, which you've learned in a previous section on how to calculate. And you could use this reaction now. Delta H of reaction is equal to the sum of all these delta H of formation of the products minus all the delta H of formations of the reactants as well. So now that we've covered delta H, now we can talk about delta S. Delta S now is defined as the degree of randomness of a system. When we have our system where we have like all these molecules built up in this one side of the container, we have a little lock here, and we have an empty vessel here, we could think of this as like the initial state. If I were to release this lock, we might think that two of these perhaps will flow over here, because this is nice and balanced. However, the interesting thing is that this is just one of the many potential microstates or positions that these molecules can find themselves in. So, the way we can calculate entropy is actually based off of this really interesting equation where S, the entropy, is equal to K, Boltzmann's constant, times the natural log of omega, which is the total number of omega, which is, so the way we can calculate this equation, so the way we can calculate entropy is actually through taking through Boltzmann's constant times, so the way we can calculate entropy is by multiplying the Boltzmann's constant, which is 1.38 times 10 to the negative 23 joules per Kelvin, multiply that by the natural log of omega, where omega is the total number of possible microstates. Now, for a given system, this can be an absurdly high number. So, as you can see, this times 10 to the negative 23 actually really comes into play and makes it a really big deal for making sure that entropy is a reasonable number. Alright, so So now that we got entropy down, we actually have covered this entire equation. And we actually have a pretty good rundown of what to expect now for thermodynamics. So now this is just a preview. I hope you enjoyed it. Please make sure to find me on gobudgo.com and request a lesson from me there. Alright, cheers.